Map fans, welcome back. Today we're going to be looking at ocean, oil spills and SAR, and we'll be travelling by map to Nigeria. Here we are in QGIS and we're just off the coast of Nigeria. So first up I am going to zoom into our area of interest, which is near to Sangana, just off the coast of Nigeria. And what I'm planning to do in this video is show you the SAR data that we can bring into Google Earth Engine. We'll be tinkering around with a JavaScript script in Google Earth Engine, then convert that to a Python script using the wonderful geemap library. We'll then bring that Python script into our QGIS interface and we can have a look at our SAR data in here. So, a lot to get through, buckle up and let's go. Like all good stories, this one starts with a tweet, and I saw a tweet by Line of Actual Control about an article on his Substack. There is a link in the description below so you can visit that original article. And what Line of Actual Control is looking at here is how SAR, or radar data, might be used to monitor potential oil spills off the coast of Nigeria. And this was done using EO Browser. Now, when I see things like this, I often think to myself, can you do this in Q? And the answer is, yes, you can. But first, let's look at the science. Olie op de golven gooien is a Dutch saying, which literally means to throw oil on the water. And as we can see in this picture, occasionally sailors used to throw whaling seamen over the side, give them a dunk and calm them down. And that's a similar idea to throwing oil on the water. Put oil on the water and it will calm the waves down. There's a great blog post about it from the British Library and I'll put a link to that in the description below. But this is the basic idea that we are using when we use SAR to try and identify potential oil spills. Now this is a complex topic and there is a bunch of scientific literature which I encourage you to start investigating. But in simple terms, the idea is that ocean water without oil will be more textured than ocean water that does have oil or surfactants on it. This is not the whole story, as other conditions can cause similar effects, such as algal blooms, and this might also not be very visible in particularly rough seas. In the original Substack post, Line of Actual Control cites this paper, stating that oil slicks would appear as dark streaks or dark patches with complex patterns on SAR images, depending on quantities and the types of oil slicks as well as the ocean's surface dynamic environment. So let's get some imagery from Google Earth Engine. Now, in past videos on Google Earth Engine, I neglected to mention that you will need to sign up for an account. So up at the top right on Google Earth Engine's front page, you can sign up. This is not a subliminal message, but an upfront message. Please do sign up before attempting to repeat this. And in Google Earth Engine, we can have a look at data sets. So I'm going to just click up here and in we go. And one of the top data sets, we've got its own tab up here, is Sentinel. So I'll click into there as well. And then if I scroll down a little, we can see Sentinel-1 SAR GRD, C-band synthetic aperture radio. And if we click into this dataset, Google Earth Engine will tell us all about how it is collected. So there is collection details, there is processing details, the bands themselves, the image properties, terms of use, all of this. Now, do read all of this because there are some intricacies in the processing that will be of interest to you if you are doing any more advanced analysis using these SAR data. But for our purposes and the purposes of this demonstration, what I'm really interested in is how do we get this into Earth Engine. And we have a sample code right here, and if I scroll down a little bit more, we can open it in Code Editor. So with this in Code Editor, we are currently working in JavaScript. And what I'd like to do is get this to a workable state, have a look at the code, see what it's doing. And once I've done that, I am going to convert it to Python. Before we start to tinker with the code, let's have a look what the sample code is doing. And first up, we are going to create an image collection. and it's going to be using the Sentinel-1 GRD dataset. In terms of polarization, we are going to have vertical transmit, vertical receive, and the instrument mode is going to be interferometric wide swath. If you would like to learn more about any of these terms, then there are extensive docs available through the European Space Agency, through Google Earth Engine, all over the place. We are then going to set up a filter, and we are going to split the descending orbit and the ascending orbit, and then we're going to make another filter for dates. We've got spring, late spring, and then summer. For our images, we're going to create image catalogs, and these will create an RGB image from the different time periods. And I think I'm right in saying that this will show us change during that time period. I'm not sure what the colours relate to. Need to do a little bit more digging on that. But we've got the descending mode, or the descending orbit change, and the ascending orbit change. And then we'll add these layers to the map and zoom in to this particular area. So these are coordinates and zoom. So let's run it after all that and see where we end up. And here we have our layers loading up. And you can see that we get these RGB images, very nice, and quite a clear split between urban, the dark areas of water, and then the coloured areas are presumably some kind of change going on in the vegetation. And you can have a look at the difference between the descending, which we've got showing currently, and the ascending. So there you can see how those two differ. Now for our purposes, the first thing that we're going to do is change this map center to where we would like to be. And our area of interest can be found at the coordinates of 5.9 and 4.3. We'll leave the zoom at 12 and let's run that. And there we are, back off the coast of Nigeria. And then I'm going to change our dates. So we've got spring, late summer, and these are all in 2015. So I'm just going to delete these, and I'm going to add in the SPs for spill, and we've got August, and the L is for late. So late August, and our filter date is going to be the 24th of August to the 30th of August. This date range is taken from Line of Actual Control's original post, and that's when they first noticed something in the imagery. Next thing I'm going to do is clear out these image catalogs, because we just want a simple image, we're not going for RGB. Then I am going to create an image, and this is another variable. It's called spill image August late. And I'm going to use the ascending filter, so the ascending orbit, and we're going to filter it by the date of late August, and then we'll take a mean of all the images, all the values from all the images in there to create a composite image. Next, I need to add it to the map, so I'm going to add the layer of spill image August late. And we'll leave the min and the max, and I'm going to give it a name, so our layer will have a name, late August spill. Okay, and let's get rid of this one because we're not using it anymore. Delete that, and let's run it, see what happens. And there we have a SAR image in Google Earth Engine. So pretty quick, all in all. We've got a similar image to the one that Line of Actual Control had in their original blog post. All this begs the question, what are we actually looking at in this image? Well, we can say with certainty that we are looking at some pixels that are darker than the surrounding pixels. That might be indicative of smoother ocean water, or maybe something else. Now this is all looking pretty good at the moment. One last thing I would like to do before we bring this into QGIS is change the colours a bit. So I'm just going to add in a colour ramp, which is going to go from red to green, and we've got a load of hex colours in here going through the steps. And if I go down to my layer, when I add it in, I've got a min value, a max value, and I'm just going to add this palette red to green, and then when we run it, now we can say with certainty that we are looking at some pixels that are a slightly darker red than those in the surrounding area. When you're researching SAR data and oil spills, you'll find that other things in the ocean can cause similar results. Things such as algal blooms, and it's also been found that this method doesn't work too well in choppy seas. So our JavaScript is looking okay. I'm quite happy with that, and I would like to bring it into QGIS as a Python script. So how can we convert it? I'll select all of my JavaScript script, so Control A and then Control C to copy it. I'm going to flip over to Sublime Text and Control V to paste it in here. Then I'll go up to Save As, and I'd like to save this as a JavaScript file, so I'll call it oil SAR. Give it a dot, and the extension is JS for JavaScript. I'll hit save, and you can see that the syntax highlights it as if it was JavaScript. Very nice. Here I've got a terminal open, and it is in the virtual environment of geemap_prod, and I have got geemap installed here. I've navigated to where my oilsar.js is stored, and if I just type in directory, you can see oilsar.js is down there. Now if you'd like more detailed steps about how to set all this up, then do let me know, put a comment below, and I'll do a more detailed video on it. But for now, I'm just going to start up Python, and then from geemap.conversion, I am going to import the lot, and in that comes good, and then I'm going to use JS to Python, and I'm going to pass it the oil SAR.js, and if I don't specify an out file, this will create a Python file with the same name. So that's run, that is complete, and I'll just quit out of this, and if I just go up to open a file in Sublime Text, let's just have a quick look, make sure it looks alright. Looks to have done something a bit weird with a nested function from the JavaScript, but let's bring it into Q and see what occurs. Here we are back in QGIS, and I've got Bing Virtual Earth up to have a look at our area of interest, and I'll be using the plugin Google Earth Engine, which provides a kind of wrapper to bring in the Python API to QGIS. If you'd like to know how to install that plugin, you can see my other video here, and don't forget to give thanks to the devs for creating such a wonderful tool. Now to use this, I'm just going to go into the Python console. I will open up my code editor, and then I'm going to open that Python script that we just created, the oil SAR py. Open that up. In it comes. I'm pretty sure that func_eq is func_e, but let's just run it and see what happens. And we should get our SAR image in coloured as before. There it is. But we do have a line going across the edge of the image, and that is almost certainly, or certainly, due to our edge masking. So let me just fix that. Okay, that should be fixed. Let's hit run. And there's our image without the edge lines in it. So, quite nice. Now, if we zoom in a little, we can see two little green dots here. And the question is, what are these two little green dots? If we go back to the original post by actual line of control, they look at Google Earth Pro and the imagery in Google Earth. So let's do that. Here we are in Google Earth Pro, and I've used the wind back thing to get back to December 2019. And if we zoom in down here, this does indeed look like an oil rig. So we know that there are some dark patches of pixels coming out of the point of an oil rig, but we still cannot say with any surety what that is. We'd need to do some more investigation. I did do some investigating and found this article in SweetCrude reports. And if you have a look here, you can see that Nostra, who reports on reported oil spills in Nigeria, in that area, you can see that Apparently there was leaking since September 3rd, 2020. So if you wanted to do some homework, perhaps you could bring in some images from September going forward. There are more dates to check out in the original post by line of actual control. Thanks very much for watching. That's been a bit of a longer video, but I hope it's given you some inspiration to go out and do some investigative work. And if you'd like to take any GIS courses, please check out the burdGIS courses page. We have a new course coming out on February 15th, and you can get huge reductions by using this link. That's on ArcGIS Pro and Model Builder. So looking forward to that one being published. As always, thanks a lot for watching. Don't forget to like, don't forget to subscribe, and happy mapping.